Hello, let us see how to evaluate a complex line integral. You are given this exponential z divided by bracket z minus 2 bracket z minus 3. So you are going to evaluate it, to integrate it along c, which is a contour given by these two cases. Z is equal to exponential e and z is equal to 4 inside these two circles. So there are two poles. One pole at z is equal to 2, and of course it is clearly inside this contour because exponential is more than 2. Then there is another one, z is equal to 3, which is outside the given contour. So the first thing, we are going to apply what is called Cauchy-Riemann integral formula, which is given by I2 pi sum of the residues along the contour by Cauchy-Riemann integral. So RC is the sum of the residues along the contour. We are going to first of all get the residue at the pole z is equal to 2, which is found by limit as z tends to 2 of z minus 2 divided by z minus 2 exponential z divided by z minus 3. Of course, z minus 2, this part here, will cancel out. That part will cancel out with that. And now, you are going to be left with the limit as z tends to 2 exponential z divided by z minus 3. Then you substitute where you have z with the 2. Denominator, you have 2 minus 3, which will give you negative 1. Negative 1 divided exponential 2 is 7.4 equal to 1 decimal place. When you divide by negative, you will get negative 7.4. Then you come and substitute the value of sum of the residue to the Cauchy integral formula, which is I2 pi multiplied by negative 7.4. When you do that, you are going to get negative I 14.8 pi. That is for the pole z is equal to 2. Then you turn for case 2. Remember, you are given two cases. Case 1 is z is equal to exponential. So we have dealt with the first case. Then we go to case 2, which is z is equal to 4. These are the contours. We go to the second case. In the second case, we can clearly see that z is equal to 3 is inside this circle because modulus of z here, it will give you 3, and clearly 3 is less than 4, so it is inside. That pole is inside. Then by Cauchy-Riemann integral, the integral of this complex line integral will be given by I 2 pi r3. 3, it is the pole. Then we calculate the residue, which is given by limit as z tends to 3 of z minus 3 divided by z minus 3 exponential z divided by z minus 2, which is equal to exponential 3 divided by 3 minus 2. After substituting, here simplifying, this part here cancels with this other one. Then you are left with the exponential z. Where you have z, you substitute it with the 3 minus, divide by 3 minus 2, which is equal to exponential 3 divided by 3 minus 2, which is exponential 3. Exponential 3 is approximately equal to 20.1. Then from there now, you come and substitute in this formula, the Cauchy integral formula, which is I2 pi, the residue at pole 3, which we have found to be 20.1, approximately equal to 1 decimal place. When you multiply, you are going to get 20.2 I pi. So now we have found that the integral along this contour, whereby our contour we have found it to be z, is equal to exponential we have found our result to be negative I 14.8 pi. And the scenario number 2, the integral of this one, we have found it to be I 40.2 pi for z is equal to 4, and the pole is z is equal to 3. So that is how you deal with the complex integral, by application of Cauchy integral and following those simple method steps. So always take your time to internalize the concept. And the beauty with the current technology is you can repeat the concept as many times as possible as you internalize the concept for yourself, so that it may become part of your system. Remember, you can subscribe to this channel and turn on the notification bell so that as I keep on sharing this content and much more, you can become part of learning. Also remember to share with the other mathematician so that you may grow together as you keep on learning this important field of maths. Bye bye, and thanks so much for taking your time to support this novel course. Remember, you can also give the comment concerning this study so that you may know the area which we need improvement, so that you may improve for your sake as we keep on learning from one another. Bye. See you in the next study.